What's the current state of development of artificial gravity with spinning space stations? Do I trust SpaceX to get us to Mars? Will China be the first to get there? And in the free edition of Q&A Plus on Patreon, why won't NASA just launch upgraded versions of the Voyagers? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Gabulous. What is the next concrete step in artificial gravity research? For human beings to remain healthy for the long term in space, we need to do some kind of artificial gravity. And the only one that we know how to do is with a rotating space station, where the space station is turning, you're experiencing an outward force as you walk around on the station, and that will help keep your bones strong and your muscles strong and help the fluid return to the right places in your body. And so far, it just hasn't been done because it hasn't been necessary. That, we know that being in space for, say, a year is bad on the human body, but we can work around it. That as long as the astronauts exercise for 2.5 hours every day, then they can stave off most of the effects of being in space. And that is much cheaper and easier than sending a giant rotating space station into space. But if we do want to live long-term in space, if we want to set up on the moon, if we want to go to Mars, if we want to understand what lower gravity does to the human body, or if we want a way to live in space without dealing with low gravity, then we're going to have to figure out an artificial gravity. And it's crazy. I always talk about this, how all of the big ideas that we have today, they were all tested out back in the 1960s at NASA, that there are amazing video of people in rotating space stations on Earth where they're like hooked up in this harness and then they're walking around on this turning wheel and then trying to do various things so they can understand what it would be like. And there was a plan to build a attachment to the International Space Station called Nautilus X back about 10 years ago. And people even proposed much smaller ones, tiny little centrifuges that you could go and sit in. So instead of working out every day for 2.5 hours, you could sit in this tiny little centrifuge for a few hours, or maybe you sleep in it. It would be very uncomfortable. And then that would give you this artificial gravity for a while, and then you would go back into the weightlessness and go back and forth. So there's a lot of different ways that we can do this. And right now, there are people who have their mind set on colonizing Mars. And we don't know what 1/3 gravity will do to the human body, what it'll do to a pregnancy. And so the only way for us to find out is for us to simulate it, for us to go and build a space station that rotates, provides 1/3 gravity, or go to the moon. But, and then if you can survive in 1/6 gravity, if the monkeys are able to gestate on the moon in 1/6 gravity, then they'll probably be okay on 1/3 gravity. But you build the space station, you run your experiments, and you learn what low gravity does to the human body, or at least to monkeys. So we're not ready to live on Mars yet. And yet people are just going to go for it. It's going to run that experiment on their babies, find out what happens. So, I think we should have artificial gravity should be a high priority. Aaron Skinner, speaking of spinning space stations, is there a certain size that would prevent motion sickness? So one of the downsides of being on a spinning space station is you get this Coriolis effect, where if the station is small enough, then you're experiencing a different amount of gravity on your feet than you are on your head. And it's expected that this will cause motion sickness. Now, you probably overcome it, but still, it won't feel like you're walking around on Earth. It'll feel weird, depending on the direction that you're walking. If you're walking the direction that the station is spinning, if you're walking the opposite direction. And the solution to this is a bigger station. And I don't remember the exact size, but it feels like it's on the order of like 1 kilometer across. Like you get to a certain size and the effect is so slight that it feels that you're walking around on Earth. But that's a big station. Jasmine Flores, what level of trust do you have in SpaceX getting us to Mars? So I'm just going to start this conversation with a plea for people to settle down on wherever you stand on this. I'm going to attempt to discuss what I think is a fairly nuanced view of this in a time which is very politically divisive. So that's my disclaimer out of the way. Don't fight. So, obviously I've been watching SpaceX for my entire journalism career, from when SpaceX was founded to their first test flights, to the first tests of the Falcon 9, to the first time that they were able to successfully land a booster, to the announcement that they were going to do the Dragon, the Cargo Dragon, the Crew Dragon, the announcement of the Falcon Heavy took 10 years, the final launch of the Falcon Heavy. And then the announcement in 2016 of Starship. And then, of course, watching all of the various tests of Starship. So I've been there this entire time watching and reporting on all of this stuff. And the larger perspective that I have is that space is really difficult, and that the timelines for this kind of thing take a lot longer than anyone ever expects. And so we always used to joke that you would have like Elon time. And so he would say something was going to happen, and you just like double and add 3 years or whatever was the number you wanted. But yet you can watch like a Falcon Heavy take off, and then the two side boosters land side by side near the launch facility, and that the main booster lands on the barge out in the ocean. Like, these things eventually go. Like, the Cargo Dragon, the Crew Dragon is a very safe and dependable vehicle for getting astronauts to the International Space Station. Starship has been a bit more of a bumpy ride, and that's because it is a entirely new spaceship, right? That you've got a fully reusable two-stage rocket, something that doesn't have to be thrown away in between your missions. And so far, getting both parts of this to function have been very difficult. And that's not surprising. Like, it is entirely new rockets, entirely new technology. It's caught by this giant tower to be able to service it. But in the question that you asked, like, what level of trust do I have in SpaceX getting us to Mars? Getting to Mars isn't that hard. Sending robots to Mars, it's been done with lots of different rockets. It can be done with a Falcon Heavy, no problem. And even in its current configuration, if you're willing to throw away Starship and Super Heavy, it could carry payloads to Mars. But I think the question that you're asking is, what trust do I have in SpaceX sending human beings to Mars on a regular basis? And that's a different question, right? That is a vastly more complicated thing. I've talked about many times that we don't know what just being on Mars does to the human body for long periods of time, that it doesn't make sense for people to live long-term on Mars. They need to be able to come home. And so you need to be able to have starships go to Mars, land on the surface, people to be able to get out safely, Starship to be able to be refilled with fuel for them to be able to get back on a Starship, maybe not the same Starship, and come home. And there's a gigantic stack of technologies, of tests, of things that need to be done for that to be accomplished. That the Super Heavy booster needs to be able to launch, the Starship needs to be able to detach, needs to be able to go to orbit, needs to be able to refuel, and it needs to be safe. And then these people to carry people, and it's got to have facilities on board this Starship for months to be able to make the journey to Mars. It's got to be able to enter the atmosphere on Mars. It's got to be able to decelerate. It's got to be able to land safely. It's got to be able to refuel. It's got to be able to take off. It's got to be able to come home. Like, there's a lot of steps to do that. And each one of those steps is going to take a lot longer than anyone thinks is going to happen. And so, with unlimited funding and unlimited runway, I think that this is an engineering challenge that either SpaceX or other rocket companies would be able to figure out over time. How do you get people to Mars, land them on the surface, and then return them safely home to Earth? But I don't think it's going to be easy. And I think that there is this expectation there's just going to be this steady stream of starships blasting off and going to Mars and settling down and building this city. And I don't think it's going to be that. I think that Mars sucks. and that there's really a fairly small limit of people who are going to want to live on Mars. It won't be self-sufficient for hundreds of years. So it's going to be this gigantic cost that Earth is going to have to bear. And I don't think there's going to be a lot of appetite for that after a while. You're like, oh, we're going to spend another $500 billion this year on keeping the Mars colony alive. Maybe that's too much money to spend. What if we cut that budget? Right? So I think that it's going to be a lot more complicated than anybody thinks. And I think that we don't want the outcome as much as we think we do. And those two things are going to conspire together to make it eventually just stop happening. That there will be missions to Mars. There will be humans going to Mars. Maybe one day we'll have a research station on Mars. But that is a vastly simpler thing than trying to create a self-sustaining colony on Mars that could last for a long time. So it's not about trust in SpaceX for me. I am unconvinced that that's even a goal that humanity will have the stomach to pursue and to pay the price that it's going to cost in terms of human lives, in terms of the billions of dollars it's going to take to make it happen. And that I think that eventually the technology will be used on the ways that make the most sense, the ones that make the money, the ones that we have the need for, launching new space telescopes, launching communication satellite networks, sending missions to the moon. Who knows? But, it's like we could build a colony on Mars, but we probably won't want to. It's time to shout out and celebrate all the new $5 patrons. Scott Hendrickson, Kevin Krenz, Shane Bullis, Marsu Nolan, Roger Russell, Peek Over Parapet, Bill Hammond, Matt Estabrook, Dwayne, and Dana Pearson. Join the club at patreon.com/universe today. Boogerman, you think China will be the first to Mars? Right now, I don't think it's clear who's going to be the first to Mars. The Chinese are going to set foot on the moon by 2030. And that's the plan. They've hit all of the other milestones. There's no argument in China about whether or not this is a thing they're going to do. They have a plan, and they're following it to the letter. And so they're building their lander. They're building the rockets that are going to take them to the moon. I think they're going to pull this off. So 2030, we should see Chinese astronauts set foot on the moon. And then the plan is to go to Mars next. And I think they're aiming to be there by 2040. So will some other nations send humans to Mars before 2040? Starship is taking longer than anybody thought, but it seems feasible that they will get the technology under control by 2040. I know that's not the timeline that they're saying, but it still feels like they could beat the Chinese to Mars. So I wouldn't pick who's going to be first on Mars. It's going to be somebody on a Starship or somebody from China on a Chinese version of a Starship. Vagge. What's the difference between a neutron star and a magnetar, and how are they made? Well, a neutron star is the remnant left over from a supernova. If you have a star that has between 8 and 20 times the mass of the sun, then as it is doing fusion in its core, it has enough mass pushing in that allows the temperature to get very high, allows the pressures to get very high, and it's able to move way up the chain of elements. It's able to get through carbon, nitrogen, oxygen, and eventually runs out of fusible elements in its core, and then collapses in on itself, and then detonates as a supernova, and you get all this collapsing material. The pressure creates a neutron star. And neutron stars, magnetars, and pulsars, they're all the same thing. They're all neutron stars, but they all behave kind of differently. So generally just after the supernova happens, then you get the pulsar. And that's because all of the angular momentum caused by, that was in the star before it detonated as a supernova, that is still maintained in the object that remains. But before, you had something that was this gigantic star, many times the size of the sun. And now you have this thing that is 10 kilometers across. It's like the size of a city. And so now they spin very, very quickly. They can spin up to 700 times a second. And then over time, they will slow down as they sort of bleed off rotational energy through gravitational waves over time. And they also can fire out large amounts of radio emissions. And then because these things are rotating very quickly and the radio emissions are sort of coming out of their poles, then you get this wobble and you'll see the radio emissions on a very regular schedule. And that's why pulsars are so regular. So that's one type. And then the other type of thing that you can get after a supernova goes off is a magnetar. And magnetars have ludicrously intense magnetic fields around them. And the circumstances that create a magnetar are still not entirely known, but probably has something to do with a binary companion star to the supernova star that goes off. And you get these really, really intense magnetic fields. Like they could tear you apart at an atomic level if you got too close. But then they probably slow down as well, just like pulsars do. And over time, the radio beams shut off, the intense magnetic fields shut off, and you're left with just this rotating neutron star. And then it will just continue to do that for, the age of the universe. And when they first are formed, they're about 600,000 Kelvin. And then they slowly cool down over time. So hopefully that describes the difference. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. This week's bonus question is all about launching a new fleet of Voyagers. And I'll put a link in the show notes so you can check that out. All right, those are all the questions that we had this week. Thank you, everyone who watched us live, as well as everybody who put in your questions into the YouTube comments. Now, we do the live show every Monday somewhere around the world at 5 p.m. But, obviously that's very random. And so there is going to be an event for when the next recording is going to be. So just make sure you subscribe to the channel, click on the notifications bell, and hopefully YouTube will tell you when the live event is about to happen next. Now, I'm going to give you some updates on some anime that I've been watching. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barely Roofing, Brian Bodie, Carradwin, Chuck Hawkins, Commander Balak, Cy Nelson, David Gilton and David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smits, Michael Purcell, Modso, Paul Roebuck, Rain Kaidu, Robeck, Sean Sargent, Stanislav Zarjev, Stephen Fowler-Munley, Thomas Ilskadron, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So as some of you might know, I am an anime aficionado, an enjoyer, and there's been a couple of really cool anime that have come out, and the wife and I have been watching them. So the first one, and this is like very traditional anime, and this is Sakamoto Days. And it is like, what if John Wick retired, put on a lot of weight, and managed a convenience store? And that all of the assassins of the world are trying to take him out. There's bigger and bigger bounties to take him out. And he has become mostly very peaceful. And he somehow is able to not only stop the assassins, but put them to work in his convenience store. And it is like many times funny, very charming, and at the same time has some great action sequences. So, but it's very anime. So, you may like that kind of thing, you may not, but I'm enjoying it. The next one that I'm watching is called Devil May Cry, and this is based on a video game series, and this is terrific. The animation is really good. It's like a Western written, so I don't like the actual production. I'm not entirely sure, but I think it was written in the U.S. and then combination of animated in Japan, I think Korea and other countries, and it's good, very funny, but also great action and very violent and well written, and so I've been really enjoying that. I haven't played the video game. I have no context for it. Now, another couple of shows that I've been watching with one of my kids is Has Been Hotel, which is on Prime. And I've really been enjoying that. And then you can watch this other show by the same creator called Hell of a Boss, which is on YouTube, bizarrely, and has tens of millions of views on these videos. I can't believe they're able to release these videos just on YouTube. All right, let me know what anime you're watching, and I will add it to the queue. I'm always hungry for watching more stuff. All right, we'll see you next week.